All right, we're gonna get started, everybody. How's it going?
Oh, you're great.
Man, y'all filled this place up. Good. Well, if we haven't met, my name is Jonathan Fussell. I'm the current president of the Astronomy Club of Tulsa. How many of you are first-time guests? Okay, sweet. Well, welcome. Glad you guys are here. Yeah, round of applause. All right. So, obviously, it is May 1st. Welcome to the May 1st meeting. We've got hopefully a good program for you. I hope you enjoy yourself. Let's get right into it. All right. There we go. I'm going to stand back here so I can actually see what I'm reading. All right. So like I said, today's May 1st. We're doing the club meeting here. And then next Friday, we have our guest night at 7:45. How many of you have been out to the observatory? Or I'm sorry, how many of you have not been out to our observatory? A few of you? Okay. Well, I highly recommend that you come out, go onto our website and RSVP. And we'd love to have you come out, check it out, and maybe join us and see what kind of telescopes you're interested in. May 15th, we're doing members only night out at the observatory. And then Saturday, May 23rd, we will be at Hunter Park doing more outreach. Going into June, so after this meeting, we actually stop our in-person meetings until September, I believe. September or August? September? Okay. So we'll pause these for the summer, and then we'll pick them back up in September. But June 5th, we have another guest night out the observatory. June 12th, we have another members night. And then Saturday, June 20th, we'll be at the Case Community Center doing outreach. And then in July 10th, we've got guest and members night at the observatory. And then Friday, July 17th, will be members night. And then Saturday, the 18th, we've been invited to Owasso for their movie night. And so we're going to go out, take telescopes, do outreach, and we're going to be there for the Super Mario Galaxy movie. More movie nights. We keep getting invited to more and more movie nights. So I really like it because it gets the community engaged, it gets people asking questions, and it's a really good time. So a little update for you all. If you've been following us for any time, we've been slowly updating our observatory. We installed a new TV. We cleaned out a lot of stuff. We've been liquidating telescopes as well to make more room. And so now the classroom has more room. It looks so much better. We've also been in the process of trying to find the best way to clean the observatory dome. Our dome, there's some chipping paint. It's pretty dirty. And so we're currently in the process of trying to find the best way to clean it. I think we're just gonna, because we had talked about doing like chemical peel or power washing, but I think we're just gonna get in there like with a scrub brush and just kind of scrub off the paint and call it good. Then we'll repaint it. What else we got? Yes, so Guthrie Green Outreach. This was our previous movie night that we got invited to. Elizabeth, our contact, said that it was the best movie night that they've had in months. Almost 2,000 people in attendance. It was a really good time. Thank you to my volunteers that helped us out. It was a lot, but it was really, really fun. And with that, if there's any event that you're even remotely interested in coming to or volunteering for, please come. We could always use the extra hands. You can either show up or let us know in advance. We're not really too picky. Just, let somebody know you're here to help and we'll get you plugged in. Okay. So for those of you who may not know, recently, I guess not recently, it's been about 2 months now, the Jenks school board announced that they were closing the planetarium, this planetarium that you're standing in right now. In response, I wanted to start a petition pretty quickly, but I didn't want it to look too self-serving. Thankfully, a student here, and I forgot to get his name, his family actually went ahead and started a petition. And when that happened, we went all in, all chips on this petition. And so I actually released this letter up here. It's an open letter to the board that we posted on social media, Facebook, Instagram, basically saying that, hey, you need to rethink your decision. This planetarium affects more lives than you think it does. People invest in this more than you think they do, and it touches more people than you think that it does. And so, yes, it's been really good to see all the outpour, all the people kind of coming together to help keep this place open. Which I'm going to let Brad here in a little bit share an update about somebody else who's going to be backing this up. But on May 11th, I will be talking to the school board at one of their open meetings, and I'm going to be making a case for the planetarium, for Dan, and that really for the students in the community. This is a place of learning for everybody. I was being interviewed by Channel 8, and one of the last questions that they asked me was, the school board had planned to turn this into what do they call it? An esports. Yeah, so esports is one that I've heard, but the other one they said like a community gathering area, which, okay, what does that even mean? And so she asked me, what do you think of them turning it into this community gathering area? And I said, it already is a community gathering area. Look around you right now, how many people showed up just for this, right? And this is just 2 people giving 2 simple presentations. Imagine if you got the word out, pushed it, how many more planetarium shows people would come to, how much more engagement and STEM people might have. And so, yeah, I told her, listen, it already is a community gathering area. And that's the case that we're going to make on the 11th. We're going to really show up and show out and tell them that, hey, you're making a mistake. You can't find the funding. I personally doubt, but if you can't find it, we'll find it. We'll come up with it somehow. And so even if it's a fool's errand to pursue this, even if they still continue with their plan of closing it, I will keep advocating for it. I know this club will keep advocating for it until the last possible second. So yes, that's been this has been my life the past week on top of school and job and prepping my presentation for tonight. So it's gonna be fun. Oh, and then the petition is still open. Scott, is that link on our Facebook? Okay. So if you go onto our Facebook page, one of our recent posts should have the link to that petition. If you haven't yet, please go sign it. It's real simple. There's no voter information or anything like that. It doesn't affect your local politics. It's literally just a signature. All right. Something I'm also looking forward to outside of club events is the MISROL. It's the Mid-State Regional Astronomical League meetup. It's happening June 26th to 28th. Excuse me. It's really fun. MISROL is a lot. It's kind of 3 days of all-out astronomy. There's food, there's workshops, there's observing nights, prizes, all kinds of lectures too. I highly recommend coming to it. I believe their website is already, Peggy, all this information is on their website, correct? Yes. Okay, perfect. Because I don't want to run, I don't want to take up too much time and run through all this information. But yes, Friday the 26th through June 28th, Sunday, June 28th in St. Charles County, Missouri. So it's going to be a fun time. We're waiting to hear back on who all the lecturers are. I signed up to be a lecturer. Depending on how this one goes tonight, I might present this lecture at MISROL too. So we'll just kind of see.
Go to MISROL.org on that's the original website on the top right corner. You can go register. She take you straight to the link.
Okay, perfect. So go to the MISROL website, sign up, come hang out, and get plugged in. And then tonight's presentations, I have Brad Young going over summer observing, and then I'll be presenting a recent paper that we're still kind of finishing up, planning to publish hopefully by the end of the summer. We're just tightening a few things in the paper. And then a special thank you. And then I think Jack Reader, he has an announcement real quick. Yeah, let's do it right now.
We have lots of recently had our club. Recently had a club, binoculars. These are 22 by 100s, collimated, and some interesting stories about how the people I met along the way and local resources we had for doing it. We'll take your time with that tonight. But what I would like to do is make a motion that we spend about $400 more on a couple of match pairs of eyepieces and some movie filters, because these things are really bright. So, if I could make a motion. Second. So, you've heard the call for the vote.
All right, let's call a vote. We'll go there. How many of you want to spend about $400 on lenses, filters? How about anybody who makes strong, you can just sort of. Okay, unanimously pass.
Okay. I'll be available after the programs. After the question channel. That was a compliment for a little further. So. Yeah, the restart.
So what they're mentioning is, if you're new to the club or don't know, we have a newsletter that goes out every month. And in the newsletter, there's a whole article about these binoculars, kind of how they came into ownership, actually how they got manufactured. There used to be a member who made these, and he's well important again. He made a business out of it.
He was a junior in high school.
Very cool.
Yeah.
Okay, thank you, Jack. Yes. They are, the newsletters are also available on the website, so not just emails. Any other quick announcements? Yes,
I'll go now. As some of you know, sorry, I'm in the back, Dan Zielinski, Planetarium. We host the telescope nights here at the Planetarium, and tomorrow is one of those nights. So weather permitting, we are scheduled to have 40 people tomorrow, and that's usually once it gets over 30 is when I try to get somebody else to man the second telescope. Jerry came last time, had a great time, and we had a great time together. I appreciate his help. But I would appreciate if one person could come tomorrow night. It's 8:30. Planetarium show and telescope night for the public. So if that's something you sound interested in, see me afterwards. I'd love to have you and appreciate your help and expertise.
all right. Thank you, Dan. Okay, and Brad, I think that's it for me for now.
There was one other question, and that was, are those binoculars available to everyone in the club? And the question is, yes, they are. They sit out at the observatory, and they're there for your use. As a guest or a member, just use it carefully and enjoy it.
So that's a yes, they are available to people at the observatory, and just be careful when you use them.
Okay, my name is Brad Young. I'm the observing coordinator, and I'd like to go through, as Jonathan mentioned earlier, we don't have meetings during the summer. And so usually what I do at the meetings is I talk about the observing opportunities for the upcoming year. And so since we're not going to have any meetings in the summer, I'd like to cover the entire summer. And no problem.
PowerPoint projector.
No problem.
Here we are. All right, start with May.
Okay, looks like the sky outside.
Or does he not have a laser? Need a laser?
No. Oh, you're gonna run the sky and not bring up the PowerPoint at all?
Correct.
I misunderstood. Okay, no, I can still do that. May, what we have in the evening sky is Venus, and Venus is actually coming up higher. It's already pretty obvious in the west or northwest, actually, when the sun goes down. But it is getting further away from the sun, whereas Jupiter, which is still high above it, is getting lower and lower. And they're going to meet for a fairly decent event, not anything really close or Star of Christmas type situation, but looks like June 8th is when we're closest. That'll still be a nice conjunction, and then Jupiter will tend to disappear into the sunset. Venus will rise up. Mercury will make an appearance there somewhere along there. Somewhere along in June, it will come up too, but it won't, and it'll pass Jupiter, but it's getting dimmer, and Jupiter's getting dimmer, and you notice how low it is. You might not see them. Venus will get to its best, actually, its brightest, actually, in July, but you might have noticed that it's getting lower instead of getting higher. And that's because of the way that our ecliptic, which is the path of the planets and the sun, is tilted in the sky. So by the time we get to August, the sun's still up at this point at 7 p.m. I think we're over that. But whenever it gets dark later in the night, Venus will be at its best. This is the date of what's called Eastern ionization. And after that, though, it will unfortunately tend to fade out as the sun leaves. And then it'll enter the morning sky and be beautiful there. The morning sky is pretty blank this summer. What we have is Saturn and Mars, and Jupiter will eventually end up in the morning sky in August. Saturn and Mars, 6 a.m. and even in June, Mars is still pretty low and dim, running very far north of the Pleiades that you see there. Saturn will rise up pretty easily. It's already visible in the morning sky, and it'll get higher and higher. And by the end of the summer, it'll be what's called western quadrature, which means it will be coming up a little after midnight. So it better be more easy to see. Mercury will make an appearance in late July and early August, and this will be a pretty good appearance of it. And there you see Jupiter starting to peak up. It won't really get great until the end of summer. But the thing about Jupiter, just to give you a little foreshadowing, is that we're about to pass through its equatorial plane, which is the line or the sort of surface formed by its equator, and that's where all its moons form. And so once every 6 years, we pass through that plane, and the satellites of Jupiter, which are already very interesting, do a lot of things like casting their shadows on Jupiter and that sort of thing. They're going to start eclipsing and occulting each other instead of each other. I've got an article that's going to appear in, I believe, the next issue of Reflector here in June that will try to describe how to see that. And if you guys are members of the club, you get Reflector as part of your membership. And if you don't get it, or if you want the article, just let me know and I can get it to you now for that matter, or you can wait until May. There is an eclipse of the moon.
Oh, this is the meteor shower.
Oh, I'm sorry. This is the oh yeah. This is even cooler. It's going to be very difficult. The moon is going to be a very old moon, less than 24 hours from, excuse me, conjunction with the sun on May 6th at 4:31. And you might have a chance of seeing it, especially if you had a clear horizon and binoculars. And then the next day, on May 7th, in the evening time, after it's passed through noon, yeah, let's go ahead and run it. Oh, I guess we have the wrong day here. So let's
You want the eclipse?
no, this is the olden moon, but we're not quite to the oldest yet.
No. This is the meteor shower date.
Oh, meteor shower.
The one that comes out of Aquarius.
Thank you. Okay, so the Aquarian meteor shower is going to be on May 6th. I'm glad you know my presentation better than I do. If you look in the east, you'll notice that the moon is old and dim, and so there will be a good chance of seeing the meteor shower on May 6th in the morning. You'll want to wait until before sunrise, because that's when the gradient in Aquarius, where the meteors come from, will start rising. Okay, and that was the big deal in my presentation from that.
Right.
Each month has sort of a thing for it.
Your June was M1 of 1-2.
Okay. So June, M102, what is happening here is the Astronomical League, which if you remember, you're a member of that, has observing programs, and they also have what they call special challenges. And this special challenge came out back in March, and what this picture is for those of you who look at galaxies or image galaxies, I'm sure you're probably familiar with M101. M101 is a face-on galaxy. Can we pull that up instead? If you know it. And what the challenge is about is there's been all kinds of controversy ever since Messier put together his list about whether or not he just duplicated his listing for M101. You'll notice that the one that he had up before is significantly different than the one you see in front of you. So what the challenge is about is to look at all of the galaxies that they think may have been mistaken for M102. And all you have to do is just image those or see them visually. A couple of them are a little bit of a challenge, but you should be able to see an 8-inch telescope if you go out to the observatory or with some kind of dark sky. And the challenge runs, you have to do the observations during June. You can't do them before June 1st, and you can't do them after June 30th. And then you just have to write up a synopsis, I guess you call it, of what you saw. And if you want to, you can make a guess as to which one you think should be M102, which one makes the most sense. They do give you some research information about it. So that's something to do in June if you want to. And you have to turn that in by the end of July.
Now the lunar eclipse.
Now the lunar eclipse, which is August 27th, and it's convenient. It's in the evening instead of early morning this time. This one is going to be a partial eclipse of the moon instead of a total, but it's going to be 95% eclipse. So in my mind, it's almost total. I mean, there will be a bright fringe on the north side. You'll notice it's got line patches there. That's the umbra, which is our shadow of the Earth. And the Earth will cast its shadow directly onto the moon and cover up 95% of it. So only that top northeast portion of it will be lit, and the rest of it will be in the shadow, which is typically sort of a dark red or a copper red. Since it's in the evening in August, probably a good thing to try to see, even though it's not total, it's still going to be a pretty good sight. And I think that was it. Except we still didn't do the whole moon movement. But I think
I'll get your PowerPoint for that.
Okay. Yeah, because we'll need the PowerPoint for the other weather. There's the Earth from the moon. While we're waiting for him to bring that up, how about going back to the moon? Anybody enjoy that? I was 6 the last time we went to the moon. I'm almost 60 now. And anyway, okay. June 14th, very old moon. Oh, actually, it's set less than 17 hours from noon at dawn, which would be, for me at least, a personal record. I mean, that's going to be a significantly challenging thing. But if you have a clear eastern horizon and the weather's good that day, you can try it. And the cool thing is, the next night, you can see the very young moon, less than 22 hours old, in the sunset. So you can do the moon, you can almost see it pass through going new. We don't get an eclipse out of it, but if you can see both of these very thin crescents, it'll give you the pleasure of doing it, and it'll also sort of animate for you the moon's passage by the sun in the new phase. And also, if you remember to do the M102 treatment. Okay? Yes, the letter from Chuck Allen III. Chuck Allen III is the president of the Astronomical League. And I asked him last afternoon if he would write a letter to the Jenks school board, much like Jonathan wrote a letter to the school board. And he turned around and sent it to Dad by priority mail. And he sent me a copy of it, what he had sent to the school board, and he sent copies for every member. And if we go to the next slide, these are excerpts from the letter, and I'll just let you read those. I think we all agree with what's stated here. I certainly do. And the one thing that I found interesting was some of the last part there. Cutting science and STEM budgets in favor of athletics, which never seem to suffer loss of funding. And I'm sorry, but as a Tulsa resident with children who are taught and gone to Tulsa public schools the whole time, when I look at Jenks, I think they have more money than God. And you look at their football stadium and you think to yourself, they can't find enough money to keep the observatory or the planetarium going. So anyway, I was very appreciative of Chuck writing that letter. I hope it has an effect. We'll see. That's the end of my presentation. So, yeah, you certainly can. Oh, hi, Peggy. I didn't know you were here. I'll bring you the microphone. Glad to see you.
I don't think Chuck Allen would get mad if I steal on him, but okay. For a while, there was the only officer in the region. I was actually brought on board in 2017 to do STEAM and accessible outreach in 2017 up at Casper, the Great Eclipse, when I was brought onto the National Council for the Astronomical League. And in 2019, Chuck Allen says, we had a junior league. I'm like, what? There's all this whole archive, really? Yeah, because I just let it go to the main office. So Rick and I drove to the league's office. I got this archive because you can have it only if you scan it and digitize it. Okay, great. Do you know what? Chuck Allen is a Toys R Us kid. He grew up in the AL. Okay? So in 1939, when AL started, it wasn't until 47 when it became a nonprofit organization. What did they do? They formed a junior league and a senior league. What does that mean? High schoolers and junior high had their own league within AL. And the adults had their own. So in all of these things I'm looking at, I sell these welcome letters, for clubs, for their student groups and student clubs. So then you find, okay, a guy has up in Omaha, decides he's got 45 students. I'm going to do the Messier with him. He writes up the Messier list for 45 students in Omaha, Nebraska. At that time, we had Gene Tandy, who was the president of AL, and Bob Wright was actually on the council helping with all the youth. He had regional coordinators for the youth in the United States. At one of the highest point, I believe we had probably 70 clubs, youth clubs only. So guess what happens? Yeah, so in these things, they get this Messier thing going, and what happens? They want to do a pin and a certificate. It was so successful, the president says, maybe we should let the adult league know about this, and maybe they want to do this too. So literally, this organization who's pushing 80, who has 25,000 members, and it's now international, has over 80 some odd observing programs, started because of youth. One guy getting involved with youth back in Omaha in 60. Chuck Allen was around in the late 50s and 60s. He and a friend from his Louisville, Kentucky club actually helped organize the youth stuff. They actually came up with a manual, and their job, even as seniors or the high schoolers, was to go in and help the elementary school kids get involved, the junior high kids. That was their goal, all right? So I think when you go talk to them, I was kind of surprised he didn't mention it, I call him a Toys R Us kid. You might be able to know that that's where he's coming from. He was raised in this organization. He helped put it together. He is a product of the very thing that this thing what's doing. So he's pushing his mid-70s. So just to let you know, AL started off and is what it is because of the youth league. It started the whole thing. Then they wound up doing a commentary thing. So just to let you know, AL really, I didn't see all of them. You need to go back to the beginning. And that's why the mid-states regionals are now going to be offering junior high school and college students. We have about 15 students coming. We have people that are donating. The registration is $25. So if you have any students that want to come, we are procuring stuff, even giveaways for them. The regionals for us are going to be including youth from now on. That's what I've been working on with everybody. So we realize the value of what you guys are dealing with here. So anyways, but just make sure you tell him that he's a Toys R Us kid from astronomy. And the other guy that worked with him, his best friend actually is Professor Emeritus at MIT in the astrophysics department. Him and the other guy that were pushing and coordinating all this new stuff. So good things come from being an astronomy nerd.
Just in case you couldn't figure it out, Peggy is much more tuned in to the AL than I am. Sorry about that. But if you want to contact her, she is the, I guess, co-leader of, or are you the leader of the BA Sidewalk Astronomy?
Yeah.
Yeah. So, you can contact her.
Facebook.
She can let you know everything you want to know about the astronomical league, but I'm going to turn it over to John.
Oh, yeah. This is a good time to your presentation. Bring up the binoculars. Venus. You can get Uranus in the same view.
Right now. No, wait, it's really, yeah, once you get past these, it really help the farm. One thing to do is also yeah, so just stay away from the sun. Last time you like 20 degrees in
All right, y'all put your hands together for Brad and yeah, it's a combined effort, all right? I can only do so much, but you all kind of pick up where I can't. Same with Peggy and Brad. Just keep pushing, keep advocating, and yeah, little by little, we'll do great things. But if we're ready, I'll get on with it, and hopefully you all enjoy this. It's gonna be a little different. Let me do my introduction real quick. Like I said, my name is Jonathan Fussell. I graduated from ORU in 2023 with my bachelor's in molecular biology and biochemistry, dual minor with biochemistry and psychology. I've always kind of been interested in astronomy. I got my first telescope when I was 13. During COVID, during lockdown, I really leaned into that. And I was already in my degree, and I was like, okay, how can I kind of steer this towards astronomy? And so I kind of started going into the field of astrobiology, which is how I wrote and titled my senior research, Stellar Nucleosynthesis of Phosphorus as a Signature for Life in the Universe. I've been the club president for about 2 years now. I've been a research associate for multiple organizations. Right now, I'm part of the NASA Study Analysis Group, number 25, that we're looking at techno-signatures. That one's currently on pause. We're our group, working group 4. We finished a little early, so we're kind of waiting for everybody else to catch up. And then part of what you'll see tonight is the work that I've been doing with Dr. Jim Cleaves at Howard University. I'm really excited to present this to you all. It's been about a year and a half in the making. And then, yeah, I'm also my master's right now in space operations through Embry-Riddle Aeronautical University, and I'm hoping to help with the Europa Clipper mission eventually. And then I also plan on pursuing a PhD in planetary science. That's to study exoplanets specifically. But that is enough about me. So tonight we're going to be talking about a network model of organic synthesis in Enceladus' ocean. So I kind of have this broken up a little differently. There's going to be a part 1 and a part 2. And so part one is going to be real foundational. I'm going to take you through like the crash course of crash courses for biology and chemistry. So you have a little bit more context for what we're actually talking about. And then if you see me sit down midway, it's because I am dog tired. We've had a busy week. I've had class dealing with the letter and all the outreach and publicity we've gotten recently, putting this together. So if you sit down and see me disappear, I'm just right here, still going. Okay, so this is probably the big reason that some of you are here tonight. How many of you have seen Project Hail Mary? Yeah, sweet. It's awesome. I think this takes it as number one for my favorite science fiction movie, hands down. We even went and saw it as a club thanks to Crystal Reyes. She's our hookup with the city of Tulsa. She's awesome. But everybody loves Ryan Gosling, right? Who doesn't? Look at that man. He's a beautiful man. But I think everybody really loves the main star, Rocky, right? Everybody loves aliens, whether you kind of admit to it or not. Even people who don't love sci-fi and convinced might be closeted fans of aliens. And so it's baked into us as a people. Think about some of the most successful franchises that are out there today. Star Wars, Star Trek, Stargate, thank you. So yeah, just go down the line of stars. But yes, so we all are in some form or fashion obsessed with aliens, and that kind of boomed after the 1948 Roswell accident, UFOs, blah blah blah. I'm not gonna get too much into that side of things. There's definitely that avenue to explore. In fact, Dr. Cleves, who I'm working with right now, he's writing a full-blown book on UAP phenomena, specifically how with all of the different observing programs, with all the different satellite tracking and all the different ground stations we have, why there isn't any other evidence for UFOs and UAP. But I digress. I might help him with that book too. I really enjoy working with Dr. Cleves. But we need to kind of get right into it and define what is astrobiology. So the textbook definition is the interdisciplinary scientific study of the origin, evolution, distribution, and future of life in the universe, encompassing life on Earth and the search for extraterrestrial life. And while I was looking for like a proper graph to show you, I came upon this one that kind of shows you the different fields and how they all sort of interplay. My fields specifically, like biochemistry, molecular biology, astrochemistry, and optical astronomy, all kind of intersect at some point. As you can see, there's a bunch of different fields. I mean, this is a lot, and I found another website that mentioned like 10 more. So there's all kinds of different ways and avenues you can explore astrobiology, and kind of all the different questions that go along with it too. And there's plenty of questions to answer when it comes to astrobiology. Like, how does life originate? What kind of environment is necessary for it to survive? What might life look like in another world? Has there ever been any life elsewhere in our solar system? That's kind of the avenue that we explored with this paper. Was okay, we know that there's some evidence out there, but what kind of networks, what kind of channels, what kind of pressures does it take to actually come to it? But before we get to that, you guys need to know the basics of life. So life needs essentially three things that can be broken down into their smaller constituents. It needs water, right? How many of you have had a glass of water today? Or how many of you have had Coke or Sprite or Pepsi or whatever, right? That has water in it. You are made 76% water. Energy, light, chemical, geothermal. For us specifically, we may not think about it, but food is energy, right? Food is derived from light and chemistry and a little bit of geothermal processes. And finally, you have schnapps, right? Not schnapps, right? You have carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And together, these create these very simple compounds. In fact, they make up you, right? You are made out of all these different elements right here. In fact, most of you is probably made out of carbon. When we talk about organic chemistry, carbon is always at the center. And you'll see it here in a little bit. Every amino acid, every branch chain, every group that you can think of, carbon will always be the center molecule, or sorry, the center element that makes up all of it. And that's because of the bond that it's allowed to create. It's allowed to create up to 6 different bonds at a time. And so, how do we know this? How do we know that, okay, it takes these 3 things, but prove it? Okay, perfect. I can. In fact, I don't have to. This is a very famous experiment, which I meant to put the name of it up here. It's called the Miller-Urey experiment. And in the 50s, this guy named, I don't even remember the first names, but Miller and Urey, 2 scientists, I believe they're at MIT actually, were like, okay, we're going to explore planetary science. Where else could life come from? Where could it evolve? How could it evolve on the planet? Answering some of those very questions that we saw just a moment ago. And they did this by simulating early Earth atmospheres, by taking what they consider primitive gases like ammonia, water, these little molecules right here, and actually simulating electricity, like lightning coming down into this gas, condensed with some water to simulate an ancient early ocean with a heat source because the early Earth was very hot. And out of that, you got very simple molecules like this. In fact, I'm going to say that now. Thank you. Give me 1 second. I bet you didn't know there was going to be a bunch of chemistry in this, did you? And so, part of what you're looking at is a cyanohydrin and Strecker reaction schemes. This is going to be the Strecker and cyanohydrin right here. They essentially come together to make, there we go, aldehydes and amino acids, all right? So amino acids are absolutely key when it comes to any sort of life, for that matter. You're made of amino acids, your dog's made of amino acids, the cat, everything. Anything that has life is going to have carbon and amino acids. And so much so that even now with science, these were samples actually taken from the asteroid Bennu. And if you can see, I don't know, it didn't really show up great on the big screen, but the ones highlighted in yellow, these were all molecules that they found on Bennu, out in space, this rock that has absolutely no atmosphere. And so now we're starting to think there's all kinds of different ways that these biological chemicals can start to evolve and show and come up. This was probably done via grain chemistry, where you have like a silicon atom that reacts with UV light and carbon and a little bit of water out in space, and may get these insane amino acids, which is really cool to see. The other place you can find these that kind of keep this in the back of your head as we move forward, these are black smokers. These are down in the benthic part of the ocean. And right now, the general consensus is that Enceladus, that we're going to talk about, actually has these. That's what the plumes are made of. And so it's really cool to kind of see Earth be a really neat analog for places in the solar system. But with this, they have found amino acids coming out of the ground. And so there's really interesting geothermal chemistry happening too up here. And so, just to kind of recap, if you don't succeed, try again. Life has surprisingly low requirements. Water, light, chemistry, little geothermal energy. Make sure you have all your elements there. You let it stir for a few billion years, and eventually you have a little guy like this. This is algae. This is a little algae cell. You know, something that always ruminates in people's minds when I talk like this, or when I give presentations like this on astrobiology and life in the universe. They're like, well, Jonathan, do you think, you know, is there any intelligent life out there? Is there anybody looking back, essentially, right? my personal take, I highly doubt it. Life took a lot of time and a lot of different pressures just to arrive to where we're at. If we even saw a little green molecule on Mars, I would go crazy over that. So less little green men, more little green molecules, all right? After a few billion years, check back for lipids, carbohydrates, amino sugars, and peptides. And guess what? You are made of all those amino acids and peptides and amino sugars and lipids. That is exactly what you are. And so, for the sake of this research project, I think it's kind of good to understand where it kind of is in the chain. So like over here, we have like the domains of life, their different constituents, kind of what they break down into as far as like kingdom, domain, family, things like that. And that's like going to be the very end goal or the current diversity of life that we see. That Luca, which is like last universal common ancestor, protocells, which I've done a little bit of work on with Blue Marble Space, but really, if you could think of it as a funnel with the choke point being right here and it expanding outward right there, there's a lot of unknowns that come from these theoretical protocells. You know, how do they form? What were the pressures that they formed? Was it chemical? Was it geothermal? And truthfully, the answer is we don't know right now. Even beyond the protocell, if you look inside, you have small molecules like DNA or RNA. And DNA, RNA molecules, that is what carries all of your genetic information. Everything that you are, how tall you are, eye color, all your genes, different genes that turn on and off to protect you from cancer, or even how like you grow, body planning genes like Hox genes. Those are all contained, wrapped up in these little strands of information. And so the point where we jump from vesicles, polymers, to some sort of actual advanced multicellular life form, it is a complete unknown right now. It's really interesting. I've heard all kinds of different theories, different ways that can happen. But the truth of the matter is right now, we're working on it. It's a work in progress. Everything from RNA theory to purple earth theory. I'll let you go check those out on your own because we're going to be here literally another, I don't know, 2 hours just talking about those theories alone. But for the sake of this paper, for the sake of this research, we're going to be operating kind of in the prebiotic synthesis to polymer side of things. Give me 1 second. I can say this part to you. So Luca means last universal common ancestor, which in biology, that's kind of like the choke point. That is the theoretical cell that all other cells stemmed and came from. And so that is its own field within itself. But like I said, this Luca and protocells and all these other theories, you could spend a lifetime on and still not have an answer for it. But for the sake of this paper, we are definitely going to be operating in the prebiotic synthesis to biotic synthesis, in a little bit of a habitable world too. All right, now we get into the fun stuff. All right, you guys remembered all your chemistry. Everybody remembers organic chemistry. Anybody remembers, what do you remember about high school chemistry? Okay, nice, sweet. All right, very cool. So yeah, this part is titled How Do You Simulate Extraterrestrial Chemistry? Yeah, so the whole crux of this paper was that when Cassini eventually got to Saturn, it did some amazing science aside from studying the planet itself, going around its moons. And for more than a decade, it was going all around through Enceladus ice blooms, seeing what chemistry is involved, checking out different radio frequencies, gravity ratings, things like that of Saturn and its moons. Before it made its fiery descent down into Saturn, fortunately, there's really no way to recover it. So they plummeted it into Saturn. It's a really cool story that I highly suggest you go read up on. But before its death spiraled into Saturn, it transmitted back a bunch of data. including the mass spectrometer readings that it collected when it flew through these ice plumes. And so here we can see this beautiful infrared taken by James Webb Telescope in 2024 of Saturn. You've got Janus, Dione, and right here, this is my home away from home. This is Enceladus. It's a beautiful little moon, little ice moon. And up here you can see a visual and I believe this is infrared mapping of the actual water vapor coming off of it. And so as Cassini is flying by, it starts flying through its south pole region that we'll see here in just a second too. This is like a top-down view. So Enceladus has these, it's actually an amazingly active moon. Saturn is constantly pressing and squeezing it, causing these essentially what we think at its core tectonic plate movement that is shifting the ice ocean beneath it to actually cause these tiger stripes that you see. These tiger stripes, these giant ice sheets, essentially. I've heard them called tiger stripes. I've heard them called stretch marks. Here's another little plume picture that Webb took. You can see the board coming off of it as the technology to detect it has advanced. And right here, you can see all the different sites where for each color was a different pass. Cassini made, I believe, 11 passes by Enceladus, and it flew through its moon or through its ice plume like 8 times. And each time it flew through its plume, it took a little measurement where it was on these different tiger stripes that you can see. It's really ice sheets. And we have the Alexandria ice sheet, Cairo ice sheet, Baghdad, and Damascus. And this one right here is actually the biggest plume that they ever detected. That's why it's in the spotted circle. So it's a really, really cool place. You can really see right there, look at that shadow, right? That's a valley of ice. We believe that beneath its ice shell core, which is about 12 to 18 miles deep, beneath it is a watery ocean that is roughly the size of Lake Superior. The moon itself is actually very small. I'm trying to think, I think it was only like 1,200 miles in diameter. It's pretty small comparatively to other moons that we know of that are out there in the solar system, including our moon. And so, like I said, yeah, there's ice plumes, swift plumes of water coming out of these South Pole regions. And that kind of leads us to our paper, and I'll let you kind of know a little bit about it. And the goal of this work is to construct a chemically constrained, systematically generated reaction network of plausible prebiotic chemistry relevant to Enceladus in order to serve as a reference framework for interpreting complex organic signals and guiding future astrobiological research. Excuse me. Thank you. And so rather than, since I'm here in Tulsa, rather than actually do this in a lab, in a wet lab, where we're actually constructing the environment, kind of like you saw Ryland Grace do for the astrophage in Venus in the movie or in the book, we did it computationally. So unfortunately, as far as methods go, sorry, I need to put that first. It's all kind of looks like this. It looks like programming. But out of that, we got some really, really cool data. But for a little more background and context, like I said, when Cassini flew through these ice plumes, it detected all kinds of different small molecules, and specifically the ones that you see over here, formaldehyde, water, hydrogen cyanide, ammonia, acetylene, propene. And you can kind of see what those are all key at doing as well. And so you might ask yourself, why do these have like pound sign, equal sign? That's because aside from the stoichiometric types that some of you may be familiar with, we had to convert this all into smiles. This is all done in smiles code. So rather than enter CH3-CH equals CH2, you just put C equals CC. And from there, the computer will take it to a database and it knows exactly what protein is. Same goes for how we did some of the reactions. If you can see over here, there's a list of reactions with how many times it was used right there and how many different kinds of reactions we had. We had 137 different reactions. It was crazy. And so I'm going to flip back and forth a little bit. This was our Gen 0 starters. So we started with all of these molecules. And from there, we started feeding it, what happens in this space if they start interacting. And as you can see, it exponentially took off. If we were looking at a log scale graph, we would just see this insane log. And so like Gen 0 had 15 interactions, 1 had 107, 2 1,092, and so on and so forth. Until you get up here, where Gen 5 had 375,190 interactions. It was a lot. We tried to go further with this actually, and we just kept running into a few issues. We think it was either code or human error. We were specifically only looking at these this like major 5th generation anyways, but we just wanted to experiment and see what all we could do if we took it to its max capacity. In a little bit more context, we were looking at 150 atomic mass units for the different data. So we worked with, I don't think I did. We worked with a group of molecules at 100, 150, and 200 atomic mass units. And our results, holy smokes, this is just from 150 AMU. We got over 30,000 different molecules. As you can see here, that's 31,513. And kind of like I mentioned, we all had to put it in SMILE ID form. Otherwise, we would just have these huge, long form stoichiometric formulas. Like I said before, experiments were attempted beyond 6, but they were recursive. We kept getting the same molecule over and over and over. And we're not sure why. It could have been a coding error, could have been user error. And so that's why we disregarded Gen 6 and just primarily focused on 0. And with the results, was really interesting percentages that came out on top. For the carbon, I was kind of expecting something like this, where obviously, the bigger your molecule is, like I mentioned, in organic chemistry, like for amino acid or peptide, the more carbon atoms are going to have. So these larger numbers that you see on like 7, 8, 9, I'm really not too surprised at all. It was the ones on nitrogen that I was really fond of. These 2, 3, 4 nitrogenous bases, or the percentage of nitrogen compared with this carbon and oxygen. To me, that was saying some form of nitrogenous base, amino acid, maybe a nucleotide. But the real question is why we were seeing these numbers. And kind of like I was saying with the nucleotides, we got ring structures, we got benzenes and phenols and pyridines and all these really cool molecules. This is just another small sampling that we had, which are all important within the context of biology, especially these benzenes and phenols and pyridines. And so taking these, we started accumulating all this data from 100 AMU, 50 AMU, and 200 AMU into this Van Crevlin plot that you see. And so the Van Crevlin plot is superimposed with various regions associated with different kinds of organic chemical compounds, like you see here, carbohydrates, sugars, peptides, lipids. And as you can see, there's a lot of overlap, and we think that might have been why we were getting some recursive molecules. We're kind of trying to hammer that out right now in some of our final analysis. And in fact, we might end up redoing this plot altogether. But as you can see, the importance of finding this is that it's very easy with abiotic reaction networks to produce compounds that occupy biological spaces. And so if you kind of think back to like high school biology, when I say abiotic, I mean these kind of compounds, these kind of molecules, the very simple, kind of everyday molecules like ammonia. We see that every day. Hydrogen cyanide, see that every day. Even acetylene, right? So the step that it takes to go from simple everyday molecules to complex biological molecule spaces is very easy. It's really cool to see this. And this is kind of the piece of resistance, I suppose. This is one of our complex reaction networks that it's called a CRNR. And what you're seeing is the degree of nodes that indicate the number of times a product node was utilized as a starting point, whether out degree or an endpoint, the end degree of a reaction. The relative magnitude, so like the size of the degree of a node, can significantly it's essentially the most utilized of all these networks. And so it was the starting point. It was the starter molecule for some of these that other molecules that we ended up getting. And you can see that here. And no surprise, water, number one, with 9,944 different nodes connected to it. And then you can just go down the list, like nitrile, 2,107, ammonia, acetylene. So as an acetonitrile, there's a lot of big words in this. And so, yeah, these top 15 most connected species of 150 AMU. And I think that's important to highlight too, is that this was only the 150 group. So it's quite a lot. You see tons of different nodes being created, connected. It's all very interesting to see. And so, kind of think back to what we were saying with the benthic zone, these black smokers that you're seeing. This is kind of like a cutaway of what we believe the Enceladus surface to be like. And we think that these kind of organic reactions are happening right down here. We think that's what we're actually seeing. When Cassini flew through these ice floes, picked it up, and we believe that it picked up trace amounts of what could be maybe some sort of biological life producing biosynthesis, which is essentially any sort of chemical or output, anything that can be detected that could be indicative of life. And so our key findings, starting with simple molecules, produce extensive chemical complexity under Enceladus-like conditions. Reaction networks grow rapidly, yielding tens of thousands of unique organic species. And it only takes a small set of molecules to act as a highly connected chemical. All those nodes that you saw. And with that, I'll take any questions, any feedback. Like I said, you are my kind of guinea pigs for all this. And so any questions that you have, you're probably going to take note of because we'd like to present this eventually. We've submitted it to the American Chemical Society. And so we're very excited to kind of lean into it and maybe present it one of these days. So Gibson, you go first.
Whenever you say you measured them with AMU, is that like that the atomic mass is right? Like that's like a general number of molecules that being done to begin with, right?
So yeah, so the AMU, that's like the atomic mass total together. And that 150 was kind of like our upper limit for that set, and then it just kept going exponentially. So
you're not working with it. Okay, you see.
No, really not. No, because think about those beginner molecules. Like, yeah, this was the only real starter molecules that we were working with. So there really wasn't too much. Everything else that you saw, like, yeah, actually like this, like all this right here, that was all populated and generated by the rules that we programmed into the computer. So a lot of when I was talking about like the reactions right here, 137 different ones. That means there was a ton of chemistry happening inside our computers. Yeah. So rather than maybe the typical like you took or you Chem 2, Chem 1. Yeah, so rather than like pushing electrons around, we're doing like full blown like reactions. Yeah. Right. So, yeah, absolutely. All right, so let's just start with lipids, like you said. Everybody look at your hands. Being serious, look at your hands, go ahead. Look at the rest of your body. Your body is made pretty darn, there's a lot of it that's made out of lipids. Another word for these are fat cells. And so when you think about fat cells, they're mainly comprised of water, right? And lipids are absolutely necessary for containing intercellular signaling, intercellular processes, intercellular matrix. Every little organelle that you can think of is covered in a shell, essentially, of cellular lipids. Yes, exactly. Your brain is made of fats, all kinds of different fats and proteins. Peptides, same thing. These peptides, you can think of them like, I think I put it in there too. There we go. All right, that's all right. Peptides, those are essential in creating amino acids. They're essential in creating proteins, RNA, all these different peptide bonds when we're talking about life. Amino sugars, these are simple sugars, essentially like amino sugars. The number one example I can think of off the top of my head with amino sugars, when you talk about the sugar phosphate backbone of DNA, that is exactly what this is talking about. In carbohydrates, it's kind of similar to lipids. Think of these as like energy cells. Does that make sense? Okay. Yes, sir, Mr. Dunn. We're working on it. I should have put a slide in here. So it's kind of like what I mentioned at the beginning. This is essentially creating a database, a pipeline for future scientists, specifically like the ones, do you all know the Europa Clipper mission? Some of you do, some of you don't, okay. Scientists that are going to be working on this Europa Clipper mission. It's a probe that's being sent out to Jupiter, or specifically Europa, where we believe has very similar features like this to actually look for life. So we're in the process of actually doing it. We're very close. I'm hoping that maybe I can be working in the lab there or in mission control when it gets there, when it gets into orbit. So yeah, we're working on that. Anybody else? Scott. Yes. Mm-hmm. Sure, absolutely. So that's kind of what we talked about a little bit within the paper, is that for these researchers in the future, we want to make sure that we are filtering out all the junk data, right? Because you're right, these are all kinds of different hydrocarbons, all these different carbon backbones, things like that. They're cool. They're really neat to see that's out there in space, but it's not necessarily for life. Now, there are hydrocarbons that you can use for life, but as far as like junk data, so to speak, yeah, there was a lot of filtering through this kind of data where it's just like chain after chain after chain after chain. So many branch chains, you're like, okay, this is gross, this is sickening. Yes, Don in the back.
Project International suggests that
Yes.
How far fetched is
This is my personal kind of opinion. I really don't know. And I say that to say this. Right now, for life, we only have one sample size, right? And that's the sample size that we have here on Earth. Now, maybe there needs to be an asterisk next to that, because there are some, what's the word? Phytoplankton. There are some phytoplankton that are actually covered in a casing of silver, right? It's essentially encased in glass. Maybe not glass, we know it, but encased in this hard shell of silicon. It's been suggested, rather than carbon-based chemistry like you and me are based off of, that alternative chemistries like ammonia or silicon could be another way that life evolves. Again, we can't really say with assurance because we're here. We don't see any other kind of carbon chemistry or anything outside of carbon chemistry that we know of. But you never know. There's been some papers into it. There's been a lot of research into it. One of the things I know with like a ammonia-based life, so the thing with ammonia and silicon is that like carbon, they can form a lot of different bonds. Carbon can form up to 6 bonds. I think ammonia can form up to 5. There's something about that one electron difference that, for whatever reason, ammonia tends to break down. I can't really expand upon it because I really don't know too much about it, but that's about as much as I can give you as far as like alternative-based life. I hope that answers your question.
Yeah, it's not impossible.
Right, it's not impossible, but it's not necessarily confirmed either. So we'll see. Maybe maybe Rocky will swing by on his way back to the air.
The water,
Exactly, yeah. Ices, or we call it Ariel for Little Mermaid. I don't know. Well, that's a good one. I like coral. Anybody else? Okay, all right. Well, we'll go ahead and go back to the main presentation. Thank you. Okay. All right. So we're gonna kind of finish it out here. But before we do that, like I mentioned before, with the announced closing and us releasing a letter and everything else, if this is truly the last time that we're gonna meet in this planetarium, which fingers crossed, right? We're gonna give it our all. We're gonna show up. We're gonna advocate. We're gonna keep pushing for this planetarium to stay open. But if this is the last time we're gonna meet here, I think we all deserve to give Dan a very special round of applause. This doesn't happen without this. Thank you, Dan. He has been absolutely instrumental over the years as we've met here. Is it 15 years, Dan? 14 years. And Dan, if you actually want to come up here, we have a little something for you. Dan has helped with all kinds of projects, different groups come up here, retirement homes, schools, homeschool groups, church groups, you name it. Yeah, Abigail, she was a Jenks student. She actually helped make a show. And she worked on the one that was Cassini. Yeah, she helped with Saturn and Cassini. And so with that, Mr. Dan, we got you a little, actually I'll let you spoil express. It's a
Oh, wow.
it's a little LED plaque. You want to turn that up for the people? An LED plaque of the planetarium. Like we said, we can't do this without you. Thank you so much for all you do. And
Plug it in the back.
okay, there we go. Sweet. So hey. Yeah, we are today. If this is it, I'm gonna miss it. There's something about these meetings that if we have it outside of here, it doesn't feel right to me. but that's just my personal take.
From my side, I am gonna try, even if it's not a public planetarium, breakfast.
Okay, then there's hope. I like hope. I can hold on to that. All right, is there any other questions? Yes, sir. None that I know of. I know we, like myself, I'm meeting with somebody tomorrow, actually to specifically talk about that. Truthfully, I don't know, that'd probably be a question for Dan. Yeah, we got a little bit of research to do. Scott has been helping me put together some great evidence and proposals to put before the board. And so we're gonna go in with data armed to the teeth. Yeah. Yeah, absolutely. Yeah, and that's something I'm gonna mention tomorrow when I meet with this lady who's kind of taken on the grant writing, the finding funding, that, hey, before we get into, because the big reason that we were meeting is to find funding for our observatory. But before we even do that, I'm gonna say, hey, let's find funding for the planetarium. So, because truthfully, it's right here in town. I dare argue this might reach more people than our observatory out in mountains. And so, yeah, that's what we're gonna do.
You gotta just go to the gathering place, look at that building. How many funders are in that building?
Yeah, truly,
8 to 10.
truly,
You
yes.
have to say, Tulsa STEM lines going to them.
Now, see, I had Tulsa STEM is somebody I do want to reach out to because I connected with them.
Yeah, they
at
have
different
grants,
ways.
they have regular grants, stand grants. I was looking
Yeah,
at that for
yeah.
the. They do one-time big large things or sustainable things, percent grant stuff there. Tulsa Regional STEM would be.
I think so too. Tulsa Regional STEM. I also want to try.
They should talk.
Well, I also want to try Discovery. I think Discovery Lab would be another good one. OU, OSU, ORU. If anybody has any connections, any thoughts, you got $1 million in your back pocket, you're willing to donate, I'm sure we'll put up a nice plaque or something for you. But we're, like I said, even if it closes, even if they continue with their plans, Dan's going to fight for us and we're going to fight as well. So, any other questions, comments? Okay. So we're going to do a group photo, if that's all right. Dan, would you be able to put up like a galaxy or something pretty in the background for us to take a picture with?
And like to see everybody. I don't know if I can do both.
Let's just
Yeah, just do a group photo.
So stick around for a group photo.
Yes, please.
Yes.
Everyone up front.
Come on. Even if this is your first time, get up here. Don't be shy.
I will. And then Dan, I want a picture of you with your plaque.
Don't sneak outside. We're documenting. Well, I gotta make sure everybody else gets in. Tell me.
And I can, show you. I need to.
Yeah.
Yeah, it's fine. Yeah.
If you don't mind people getting on top of the platform and. Dan, we might need lights, yeah. Actually. I do not have a flash. That's the only thing. I have to hook it up, but I don't have.
We've got more space back here on the platform. More people want to try and get up there.
Yes.
No galaxy anymore?
No, right. What you have right now is pretty good. Is good.
Might need a-
Well, if I could have some of you guys actually move to this side, and then I could have, ma'am, if you could step up on the platform, that'd be great. And then Dan, come on, please. And John, you gotta get in too. Okay. Just give me 1 second to adjust this really quick. All right, ready? Everybody look here, smile. 1, 2, 3. Great. Let me fix something. Okay, ready? Smile. 1, 2, 3. Great. Thank you guys. And then there you go. Flat. Okay.
All right, thank you, everybody. And I think that's it. All right, I think that's gonna call it. Thank you all. Have a good night. We'll be here answering questions. I think some of us are going to Red Robin. If you want to go to Red Robin. Yes.
Oh, that's your wife. Yeah. Oh, I see. Right. Oh. Yeah,
Yes.
That's